Flow diagram. It helps to visualize the big picture of your solution. It is used to describe processes in any area. It doesn't mean only for developers, it's for any particular area that involves to follow procedures. For programming, it's essential when you want to show someone how is the implementation or how it is your software working. It helps to explain to non-programmers about software processes. Advantages. It helps to find problems before writing an algorithm. After finishing, the algorithm described on the flowchart can be translated to any program language. It helps to improve your coding skills, giving you more insights. For instance, you start thinking more logically and thinking how to avoid problems. So here we have an example. You can see there are some symbols that you will need to learn to describe some process, to describe input, output, start, stop. For here we have the start, then we have the declaration of variables to do a process. They have with input, output, and then we have a conditional, and then we have the finish of your program, and then depending on the condition you will do some other task. Here we have a second one, is a loop, start loop. There is a condition, then if the condition is true, execute this statement, increment, and then keep in the loop until the condition is false and you finish the end loop. So the symbols, first we have the flow line used to indicate first we have the flow line used to indicate the flow of logic by connecting symbols. Then we have the terminal stop start used to represent. Then we have the terminal stop start used to represent start and end of the flowchart. Then we have the input output used for input and output operations to receive data or to send data. Processing used for arithmetic operations and data manipulation. Decision used to represent the operation in which there are two alternatives, true or false. On-page connector used to join different flow lines. Off-page connector used to connect flowchart portions on different pages. Predefined process function or subroutines used to represent a group of statements performing one processing task. So here we have another example. Start, then we have a condition, then we have the processing, then we have another condition, processing, and the end. Or we have here a loop depending on the condition. Here in this link you can go and click here. You will find more information, more examples for you to understand and get used to the flowchart. The use of subroutines, you can see here call factor. As you see on the symbols is the predefined process. So here we see the use of this. We have the call factor, and then we see that the subroutine or subfunction or function is defining another flowchart. So your program will start here, initialize the pointer, get the number, if the condition is false, will load the counter, and then it will jump from here to here, factor, it will run this code here, then when it returns, it go back to factor and then continue with stored result and end. Here there are data for subroutines, so you can go there and